Hi guys, not sure if I'm audible or not. Just checking few of my settings. Alright, so let's just get started with this particular question. This question actually came into the contest once, and like in that contest, I was not able to solve this particular question. So I've just gone through the concept of topological sorting and how it works. Still, like there are few things that I don't know about it, but I'm just gonna give it a try. So resetting the stopwatch. Alright. So you are given an array complexity of length n. There are n logged computers in a room from 0 to n minus 1, each with its own unique password. The password of the computer I has complexity I. The password for the computer labeled 0 is already decrypted and serves the root. All the other computers must be unlocked using it or another previously unlocked. Okay. Like I have gone through this question once, so I know what basically it does. It is saying. So it is saying that you can decrypt the password for a computer I using the password for the computer J, where J is any integer less than I. Right. So this is an important thing and with a lower complexity. Cool. So this is one rule of it. And the other rule is to decrypt the password of computer I, you must have already unlocked computer. So basically I is depending upon J. Once J is resolved, then only you can solve the I. So it's kind of DAG, you can say, like I is dependent upon J, right, and J might be dependent upon some J minus 1 or something, right. So in this kind of problem, what we can do is we can find the person which is already unlocked, that is 0. There are the password for computer is already decrypted, right? So we want to decrypt the password, and 0 is already decrypted. So you can say something like that. From 0 you can go to J minus 1, then from J minus 1 you can solve J, then I. Cool. But one of the thing is, right, that complexity should be less and index should be less, right. So that means you can have something like this, that J should be less than I and should be less than complexity I. So if these two conditions are meeting, then this means that you can solve this particular, like you can solve the decrypt the password of I using password of J, right. So I feel if I am able to create an adjacency list, or you can say a graph or DAG, right, which represents the dependency, that would be actually very helpful. And since it's a directed kind of, it's going to be, I think, directed kind of graph. So the first thing would be to create the DAG. And how can we create? What do we have? We have the complexity, right. We have this complexity, okay. if I want to create a DAG from this complexity, what do I want to do? I'm just thinking from a brute force approach. So I can actually start from index equals to 1, and I can go back and I can keep checking that okay, whether this particular index can be solved by this current index or not. If yes, then you can say I is dependent upon that particular index, right? But is it going to be a feasible way? Because this way, what we are going to do for each and every I, we are going to look out all the elements before that. So it's going to be n cross n, because n times we are going to take to iterate over this particular array, and then n minus 1 time we are going to take to check all the previous values. What we can also do is we can keep track of the I'm just thinking minimum is not gonna work, maximum is not gonna work. Okay, suppose if I know the, like if I minus 1 can be solved by, or you can say I can be solved by I minus 1. So if I minus 1 is dependent upon any of the other things, right? I should be dependent upon those. That is going to be there. And the other thing is, yeah, I think let's just leave it. It will not take time, because there might be some other I, like I minus n, where complexity is actually greater than this particular thing, but it is less than this. So it's not solving this one, but it's solving this one. So we are actually going to ignore those kind of entries. Right. So let's just see. What I'm going to do is, my idea is to create the DAG, and from the DAG I do the topological sorting, or if in a way I can actually write in how many ways I can write the sorting, that would be actually, I think that would be well better. So complexity dot for each of the complexity, what I'm gonna do, instead of this I can do dot tail dot hold left. Here I'm starting from 1 actually, because index 0 I already know that is unlocked. I can also create one adjacency matrix or list first, and well, adjacency array dot of dimension. I'm just thinking, is it going to be of dimension or not? Array of int. Is it? No, we need a map here, right? So Scala dot collection dot mutable dot map int comma array of int dot empty. Not sure, or we can also do like this, right? and we can keep this here. Do we need to keep it here? It's a mutable map. I don't think so, but still I'm just keeping it, doing this. Now what I need to do is, we know that 0 is going to be there as a dependency for this particular x. Yeah, so not able to actually get to the. I was thinking, because the main goal of the problem is to actually create the permutations, and here I am actually getting stuck with adjacency list first. So what do you think, how I can approach this? Just thinking. Because what is going to happen here, like I can also do zip with index, because I need to know the index of this particular thing. X value comma index. What else do I want to do is acq equals to acq plus value equals to, or instead of this, let's just have the array of integers first. Val current dependency array of int I think it's also like this, array dot int dot empty, but I'm not sure if it's gonna work. And let us just find out the current dependency, okay? So what are we going to do here is that complexity dot take index so take will actually take from left this many elements. So if 5, so 5, 1, so 1, so I will say just index plus 1, or you can say index only, so that is actually gonna work. And then I will just do for each. Do I need to? I don't think so. I will do filter this value of the complexity should be less than actual value. Okay, so I can just directly say this is the dependency, right? And then I can create this, like I can add the value to I can keep it as new map equal to acq plus x pointing to current dependency. If right? Then returning new map. So this should actually give me well adjacency map, adjacency map, and I can try to print line adjacency map. Adjacency map dot map map dot what is this thing? D dot 1 or you can say something like this, dot map p print line s key Alright, let's see if this is gonna work. I'll just return one for now. So make it just compile it. Okay, so this is not working. Scala.duration.mutable. What say? Expected this. The issue is here. Line number 24. Dot map expression expected, but okay. Do a chat GPT actually just to know how to print line or map. क्या बात है? क्या बात है? line number 18. Filter. How can this happen? This happen on int array int and require this. You can say value alright, so these things are like sign patterns. New map. I did it not to value. Just seeing if the I don't know. Let's just check this. Oh, okay. Plan. Value current dependency. Hash map. Hmm. Already there. Case key values. हाँ तो कोई ऐसा डिपेंडेंसी है ही नहीं कौन सा होगी कौन सा send. Okay, but yeah, the dependency wise it's working, right? But one thing is like 3 1. For 2 it's just 1, for 3 it's 1 and 2. Okay. Alright. Complexity take index. Okay, so but we want the not the index, not the complexity itself, right? Value index. Here we are making it for value. No, it should be for index, right? for this particular index this is the dependency, and for those these are the indexes. So and here also we need to zip with index, and now we're gonna have till index, then filter this, then I think we can just do collect. Collect case exif. Collect case x or case d if d is less than, can't say d, right, because now you have complexity comma value case this if index if complexity is less than value, so just keep the value, I can say keep the index. I didn't think so. Let me just check now. Indentation error. Okay, so yeah, 1 is depending upon 0, 2 is depending on 0, and 1. Cool. Now, what do I need to do is there are certain stubs, right? I'm just thinking, how to approach this particular problem. In this particular adjacency matrix, I can add update 0, comma like array dot int dot empty. I'm just thinking like how can I also mention the in degrees? What do you mean by in degree? In degree is just like how many other people are actually dependent upon you, right? So that's how it comes, because we need the in degree for topological sorting. Or if you are going to dependent upon any other person. If you are dependent upon any other person, then that is a bad thing, correct? Because you can't actually start from them. So values, the val 0 in degree, array of int, I will just first add 0 here because it's always gonna be there. Now if current dependency is empty, then I will just add 0 in degree dot append element which is index. So I'm just trying to print this particular thing. 0 in degree. And case string. Right. Let's see. Jamela, 0, right? Here we also have 0. Well, 1 is not dependent upon anything, 2 is not dependent upon anything, so why we don't have them? Because you can say var 0 degree equal to this. It's returning a new actually element. 0, 1, 2. So 0, 1, 2 are like not dependent. So you can say they are solved. Really? Let's just check. 3, 3, 3, 4, 4, 4. So I mean, how can you solve 3? They don't have any dependencies, so you can't even solve them. So it's not possible to solve the second one, right? Output 0. Correct. So you can say there is any other, like you can say something like this. But if 0 in degree dot length not equal to 1, then you can just return here as 0, or just move forward instead of using return like this. Cool. Right. So since now we have this, and we know that, I mean, what do we have here? Let's just think about it. We have 0, which is the starting element, and then we have adjacency map, and this contains dependencies number of right. So basically it's also showing the order which like this is dependent. So for to actually solving this, we need to solve this. So if I start from the last, I can see, okay, I mean, this is dependent upon these many. Pick up any one of them. Right. And then for each one of them, I can pick up any other one of them. But it's like that, if I have picked up one, then this time I can't pick up the same. Right. So the permutations should be I think start from last, check upon how many indexes current element depends upon, then pick up any one of the element, then I was thinking from reverse order. So this is the last, and you have 4 or 5 elements that can be solved. So you have, that means 4 particular permutations that can happen, right? If you actually anyone, and you need to go into that, right? I have the DAG. Now I want to print the topological sorting. So how do you think I should get started? I can print any one of the sorting order. I can just how to print all the topology, how to count how many topological sortings can be done. DAG, I already have created the adjacency matrix list above. Degree trying. All nodes. Do this. I'm just seeing if it's gonna work or not. Count all topological sorts. What expect is map list of int. So compiler line number 125. Affected. only fix the count for number of topological sort orders. जब मिला इस तरह खुदा एक सही लगा आउटपुट एक आ गया यहाँ पे और वहाँ पे दो आया 0 0 0 1 2 0 2 1 डिपेंडेंट नहीं है why the answer is as 1 for 1 2 3 0 1 no as for this either 0 1 2 or 0 2 1 Okay, stream, I'm just pausing.